One thing to always remember about TDD is that a red failing bar like we see now is the green light for us to be able to go into the code and modify implementation to make the test pass. When we have passing tests, we would never ever add or change existing behavior in the code without first having a test, testing for the new behavior and thus failing. So with our red failing bar, let's make the test pass. It's failing because our assert.requal is expecting 5 and we're returning 0. Now, to make it pass, we really need to only add enough code to get the test passing. So I'm going to go into the code and make the method return 5. And this is going to seem a little odd for now, but follow and I'll explain why later. So back into my production code, I know that my test is expecting 5, so I'm going to return 5. And just build the solution. And back to NUnit. Now NUnit's clever enough to reload the DLL when you've recompiled it. So what I'm going to do now is run our test again. And there we have it. It's now passing. So step 3 of our TDD, of making the test pass, is now complete. And now that we have a green bar in NUnit, this is the indicator for refactoring. When we have passing tests, the only thing we should be doing in the code is cleaning, generalizing, and refactoring. This is where we can really start shifting code around and inlining methods and removing duplication, etc. And as we refactor, we constantly keep running the suite of tests to make sure we're not breaking behavior in the code. If we break something, we'll get a red bar, and then we'll need to take small steps in unwinding what we've changed to understand what caused a break. And unfortunately at this point in the math example, we've not got much code at all to refactor, so we can skip the refactoring step here. Now it's time to explain that hard-coded return that I implemented earlier. Though the test is meaning well, if we just go back and look at the test, though we're checking that the sum method is working by adding two numbers together, this one test alone isn't enough to really know that the method is working correctly. So I'm going to write another test that's going to exercise the sum method further, and this new test will assert that another set of input parameters that I give it do not equal a number that I wouldn't expect it to return. So I'm going to implement that test now. So notice here that I'm now using shouldn't as opposed to a should. So this test shouldn't sum two numbers incorrectly. And I'm going to say again that it's great practice to use the should and shouldn't style of naming your tests, and this will get you thinking more of the behavior in the unit of code that you're testing. Notice also how I'm now using the are-not-equal method in the assert object as opposed to the are-equal I did in the first test. So I'm expecting that the 10 plus 10 calculation that the sum method is going to do is not going to equal to 5, which would make a passing test. So I'll compile this this bit of code now. Whoops, we're missing a in bracket off our method, and then we'll jump back into NUnit, and we can now see that NUnit's reloaded our new test. And okay, now I'll run the test again, so I'll right click on calculated test, click run, and there we go, we have a failing test again. And if you remember what the red bar means, we can now modify the code's behavior. So I'm going to go back to that test and try and make it pass. So back into the calculator, I'm going to put the real implementation of the method in now. So I'm going to compile that, back to NUnit, and run, and there we go. another successful passing test. So there we have our sum method with 2 unit tests and the green bar, all is well. And whilst we're in this passing test mode, for the sake of demonstration, I'm going to utilize that step 4 refactoring that I mentioned earlier in the TDD process to refactor and clean up some code. And the code I'm going to tidy is actually in the test code. When we're refactoring, there's no rule around refactoring the test or the production code. So what I'm going to demonstrate is NUnit's another attribute in the NUnit framework called the test case. And for our should sum two numbers correctly method, I'm going to remove, if I just come back to the tests, so for this should sum two numbers correctly, I'm going to be removing the assert r equals, and I'm going to use the test case attribute to run multiple I'm going to run this method multiple times with different sets of input data into the sum method. And the newly changed method is going to go a little something like this. The test case attribute allows us to pass inline data when invoking the test method. The arguments and the attributes will be passed into the two parameters that I've added to the test method. The test here will be run 3 times as we've defined 3 attributes. The result parameter of the attribute is the value returned from the test method that NUnit will use to verify that the test ran successfully. So a quick compile and jump over to NUnit. We're going to run the test and see if we're still passing. So we can see our 3 new tests now have appeared in NUnit. So if I right click on calculated tests and run, we can now see all of our tests are still passing. So one last thing to show you before we finish is the ncover tool that was installed when we installed testdriven.net. If we right click on the test project and run with coverage, ncover Explorer will launch now and give us a nice coverage report over the tests that we've just ran. We can see that we've got 100% cover over the tdd example.math assembly, and we can drill down and see the namespace and the objects and even the methods that the code's ran over. The tests that I've exercised. It's always a good thing to try and keep code coverage pretty high. However, it's also good to keep in mind that it's practically impossible to achieve 100% code coverage as you get into more complex projects. Because as you might find out later in more experience in TDD, that when you start using generated code from any kind of tool, it's extremely difficult to test that generated code because the implementation details are really out of your control. So that completes our demonstration of a Hello World style introduction to TDD. I hope you've enjoyed it. Please feel free to leave any comments below. The upcoming videos will prepare us with the techniques to begin applying TDD to real-world problems. We'll address more complicated methods with much more complex logic than our sum method that we've got here. We'll dip our toes into the world of mocking and test doubles for unit isolation and other common TDD patterns. We'll also be looking at refactoring legacy code and how we test for exceptions and forcing exceptions through code to exercise behavior, which we'll get to show off more of the NUnit framework features. Thanks for watching.